This is Parasitology Seminar for December 2nd, 2021. Infectivity, a Broad Perspective. As you can see, what I'm looking at is the Bernie Sanders at the inauguration of Joe Biden as an infective meme. And this is one example of things that sort of move through populations like various infective agents. And this is really a good example of it. For example, if you do a Google search on Bernie Sanders mittens, there's 17.5 million hits less than a month after he appeared on television. And that meme not only spread through the internet, but also then generated production of mittens that looked like that. So today, to talk about infectivity in a general way, I'm going to pull some ideas from 3 books that I read once, from a Henrik article in American Anthropologist back in 2001. Talk a little bit about, maybe indirectly, about the mimetics literature, some news reports from credible sources, and end with Matt Bullock's doctoral research and the ideas that really came out of that, which I've done before. The 3 books started with Peter Farb's 1973 publication, Wordplay, and for any of you who are contemplating being a teacher or interacting with people in any seriously professional way, I strongly recommend Peter Farb's book. It will open your mind to things you never really thought about before. Second one is 1981, Cavalli, Sforza, and Feldman's Cultural Transmission and Evolution, of which I have a signed copy. The first chapter is the educational one. The rest of it is a couple hundred pages of differential equations. But this is also a powerful piece of literature. And the third one is Douglas Hofstadter's Metamagical Themas from 1985. And I would say that this particular book has probably done more to really shape my whole intellectual life than anything else that I've ever read. Here are some quotes from those books. Peter Farb talking about people in a group. Most listeners are amazingly trusting. Their lack of discrimination about a speaker's credibility can be observed at any social gathering, and my guess is that all of you have actually seen that happen. Cavalli, Sforza, and Feldman do it a little more directly. Another model can be used, and he's talking here about the movement of innovation through populations. Another model can be used. Some senses may offer a more satisfactory interpretation of the diffusion of an innovation, and that is of an epidemic. And I think that he has some examples here later on. And finally, Hofstadter, viral sentences, as Walton called them, are those that seek to obtain their own reproduction by commandeering the facilities of more complex entities. And that, I think, we can always understand. Hofstadter actually, this statement really applies to all animal parasites. Hofstadter gives us a couple of examples. He calls one of them System S, began, blah, 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 all these different statements, and then ends with, it's your duty to convince others that System S is true. And that is really kind of the essence of what I would call classroom lecture teaching. He illustrates it a little more, what I would say, convincingly in a way, where he says, here's another system I'm going to call X. Anyone who does not believe in System X will burn in hell, and it's your duty to save others from suffering. And that's an example of a system that becomes increasingly infective, and I think that most of you can put words on those. The Henrik paper involves cultural transmission of innovations and how those innovations are really adopted, what makes them happen. And he talks then about biased cultural transmission as the predominant force. And I would equate biased cultural transmission with perhaps host specificity. So parasite-induced host behavioral change, that's a reasonably hot topic nowadays, and if you actually do a search on the BIOS Web of Science database, you get 38,500 hits on those two terms, parasite and behavior, with the asterisk, of course, pulling in all of the other letters that follow those base terms. But only when biased cultural transmission is the predominant force in the new behaviors. That's where he talks about the S-shaped curve dynamics. Well, what are the S-shaped curve dynamics? And this is an example that Henrik uses from a Ryan and Gross paper in 1943, the diffusion of hybrid seed corn in Iowa farming communities. So transmission of knowledge, I'm going to equate to infected by knowledge. And once the knowledge changes behavior, that results in this instance of the adoption of hybrid seed, all during the 30s. So here's a case in which I would assert that these Iowa farmers are becoming infected by knowledge, and that knowledge alters their behavior, and that knowledge probably comes largely from a biased cultural source, like Henry claims, mainly other farmers and brochures and advertising and what have you. Cavalli, Sforza, and Feldman use exactly the same bunch of people, namely Iowa farmers, and this is another innovation, the adoption of 2,4-D weed killer among those corn farmers. And again, we see the infection with information on the left and the change in behavior on the right, resulting from that infection. And I think that what's outlined there in red, you could probably attribute to Fauci talking. Advice from one or more experts may be influential. Maybe, of course, is the key phrase, because it's not always. But nevertheless, that would be biased cultural transmission. So Cavalli, Sforza, and Feldman tell us that words and phrases move through populations like infectious agents. And that movement is largely then horizontal, and what you're seeing here is a quote from that book that talks about the setup of their mathematical analysis of horizontal transmission. Here are some technology vectors, and I'm borrowing now a phrase from Matt Bullock, one of Matt Bullock's papers, Avenues for and Constraints on Transmission. And I think that whole concept of the avenues for and the constraints on as a basic way of thinking about the movements of infectious agents through populations, I think that turns out to be a pretty good one that kind of keeps your thinking aimed in the right direction. What are some of these vectors that actually enabled parasitic ideas to move through populations? Mac Portable in 1989, DVDs, Netflix, Facebook, February 2004, Twitter, the iPhone, and of course recently Zoom, which some of you are using right this very minute. There are three biggies, some examples, some three really big ones of the past decades, the Me Too movement, the Black Lives Matter movement, and of course MAGA. And these were really little more, I say little more, but mainly letters and words and a sign, the pound sign. And these memes really carried along with them pictures and ideas and changed behaviors. Well, here are a couple of minor ones that I picked up, again, just to illustrate things. Some of you, I believe, have either talked about cases in which you're referring to numerous items of some kind, whether it be cars or worms or what have you, and you've used the word amount, when in fact you probably should have used number. Or you've heard somebody talking in this way: oh, the amount of cars on the street, I was late because of the amount of cars. Well, in your mind you're thinking now, number of cars, you idiot, number of cars. You don't, you count cars, but you weigh things like sugar. How much sugar, what amount of sugar do I put into a recipe when I'm baking a cake or making cookies? So when I prepared this seminar and sort of checked on Google, there were 2 billion hits on this query in half a second. So there is a lot of discussion out there in cyberland about the use of these two terms and the way they are used. And I would almost bet you right now, Beer, that if that now, having heard this little discussion of amount versus number, then you're going to either notice yourself using those terms incorrectly, or you're especially going to notice when other people use it. Now, having been through some editorial, being on the receiving end of some editorial commentary about book manuscripts over the last 2 or 3 years, picked up another one which has very, very slowly entered the English language, even the official uses of the English language, like newspapers. And that is the use of plural pronouns in a singular context. And if you consult the Chicago Manual of Style, you'll find that it's really now allowed. And so instead of writing a sentence where you said he and she or he or she, in the past you may have replaced that with they or theirs. And that gets, again, nearly 18 million hits in less than a second if you look that up. So here are cases where words are the equivalent of infections, changing behaviors of hosts as those hosts are talking or writing. When I went back through the language that our nation and probably the world has either acquired or used differently than they had been using in the past as a result of COVID infection, I came up with there are at least 39 words that have either infected the American population and changed behavior since the 1st of January in 2019, or they've taken on infective properties and they've taken on characteristics, for example, either becoming more infective or more pathogenic, or carrying with them properties and affecting that infection that they didn't have before. So here are some of those words. Masks, social distancing. How many people really talked about Pfizer and Moderna regularly before COVID hit? How often did you hear in sort of non-parasitology circles the term CDC, stimulus package, portable morgue? You may have heard about a portable morgue, but that early in the pandemic in New York City, that became a real word that moved through discussions. Anti-vax, that was clearly present in the population before COVID, but it really has taken on an example of one that's taken on a very different meaning. Here are some other ones: pangolins, J&J, VaxCard. I noticed that I have Pfizer on there twice and Moderna on there twice. So N95, all of these words, and I just happened to pick some of these that came immediately to mind. Well, the sort of the basic model, or I should say the basic way of looking at epidemics, is to use the so-called SEIR or the SIR model, which I would say, a sort of standard, standard way of looking at the movement of items, infectious agents, through populations. That model is dependent on Leslie matrix for its application, and Leslie matrix is one in which you multiply a columnar matrix with a square matrix, and in this case the n's, n0, 1, 2, 3, n, are the numbers of individuals in a population that have the particular traits that are either S, E, I, R. And then across the top, the F's are the traits themselves. And the S's, in this case, are the probabilities of moving from one state to the next. So S sub 0 would be for moving from exposed to infected. And the results then are what happens in the next population, and those are the pink numbers on the right. And so, and this is done iteratively, depending on what those S values are, it can produce different kinds of trajectories of a disease agent through a population. So here's a case of what something like herd immunity would look like. And again, I don't have the actual numbers there that represent the S values, but in some cases, depending on what those numbers are, with an effective vaccination or truly acquired immunity to some disease, in this case it would be some relatively mild one, the disease itself or the infectious agent would more or less disappear from the population, and the population as a whole would become immune as a result of acquiring that disease, or relatively immune. And again, depending on those S values, those transition values that you put into the equation, here's another result of the Leslie matrix, in which you have a disease that is endemic, but in this case is a fairly low level. And you're exposed and you're susceptible, and your recovered classes sort of begin to approach an equilibrium. That model has been applied to the COVID-19 epidemics, and these guys really talk about the complexities of that current epidemic and the values that result in the transition of humans from one state to the next. Finally, we discuss the control strategies of those of the virus based on the structures and parameters of the proposed model. Well, what does their proposed model look like? So first of all, they describe the variables, and again, susceptible, exposed. A couple of different subcategories of I are infectious, and that is without intervention or with intervention. And intervention in this case can mean a number of things: recovered, quarantined, or hospitalized. So in this case, the recovered, a couple of subcategories have new categories, I guess would be the right term, have been included. And when you see the figure, without going into it in a great deal of detail, there are parameters that take on different values in the model. Is this list of here? And I think you could probably do this with any parasitic infection out there in nature. Although the real question would be, for example, if you're talking about tapeworms or roundworms or protistans of some kind, is there really a resistance in the sense of there would be, to a successful infection and recovery from something like measles? So here's the picture that they used to illustrate the complexities of the COVID pandemic, and you can see in the equations, if you actually get into those and look at their two tables, are really not all that sophisticated, and they're pretty easily understood. And if you went out into nature and decided you were going to apply a model something like this to your chosen host parasite, animal parasite system, then you would have really a nice doctoral dissertation on your plate. Talk a little bit about the bolic perspective. Parasites have avenues for and constraints on their movements through host populations. And again, I claim that this principle applies really to all infectious agents, regardless of their form or transmission mechanisms. And it's really kind of a simple and obvious way of looking at parasitism until you start defining that term infectious agents in the most general way you can. That includes technical innovations and words and phrases and ideas and pictures and memes of all kinds. So here's sort of Bolic's kind of workhorse picture, and I think you're all totally familiar with this one, namely the life cycle of a frog lung fluke. This one would be straight out of some textbook like Foundations, although redrawn really in a mass way. Here's a quote that applies to that. We work on the avenues from Matt's website, actually. Avenues for and constraints on transmission of frog lung flukes and the role of second intermediate hosts in these life cycles. Most frog lung fluke life cycles have been shown to use odonates, a second intermediate host. However, there is a lot of variation in the use of those second intermediate hosts among congeners of frog lung flukes, and that variation in the use of second intermediate host is really the demonstration and the understanding of the role of those second intermediate hosts as either avenues or constraints on the movement of those parasites. That really sort of set Matt on his way to success in a lot of ways. For example, we could just simply take that previous COVID table, and instead of humans, you could take something like Hematolicus complexus, that frog lung fluke life cycle, and describe your parameters in some different terms. Alpha would be either hidden or out of reach, going all the way down. Recovery rates of infected individuals, those would probably all be 0. The transition of exposed to infected classes, that you might, with the right amount of field work, be able to figure out. The rate of change from isolated to stays uninfected, so isolated in this case would almost have to be physically isolated from those second intermediate hosts. So here, you might kind of try this in your mind and see what would happen if you set out to actually apply that model to some frog lung fluke like you might find in Nevin's ponds. Or take the system of your choice, and here's one that's straight out of Foundations of Parasitology. And you might ask, what really are the avenues for transmission, and what are the constraints on transmission? And the avenues are really the presence of definitive host species, the presence of adequate intermediate host species, the physical environment that does not destroy an intermediate stage of a parasite, and vegetation that would dictate either the availability of potential intermediate hosts or their physical distribution within an environment. So all these factors vary, and with variable probability curves dictating the extent to which they are either avenues or constraints. And some of the constraints, and we can say the same thing really about the about the constraints. So constraints are host specificity, and parasite infective stage encounters the wrong host, one that does not support development, and that's a constraint on transmission. Infection site specificity, again, all host ecological niche may somehow or another either function as either an avenue or a constraint. Abiotic factors like temperature, for example, seasonal phenomenon, all of these things function, again, both as avenues and constraints. So, in your mind, you can think of parasite life cycles and transmission events out there in nature in a certain way. In my view, there are far more constraints than there are avenues, and the constraints are far more variable than are the avenues. And I would say this situation with animal parasites is just the opposite of what you find with cultural transmission, where there really are not so many constraints and there are a lot of avenues. So, for example, you could take that last picture and pluck out the bluegills and fill in the boxes with a host species of your choice, and then start putting values on those parameters, and putting values on the variables, and see where you would go from there. My contention is you could probably do this work if you had the right kind of ecological setting and a number of different ponds that you could manipulate and so forth. It would be a non-trivial doctoral dissertation, a truly non-trivial one, when you actually set out to do it. Okay, does SEIR thinking apply to systems beyond disease transmission? And of course I wouldn't be giving this seminar if I didn't believe that the answer is absolutely yes. So what are the avenues? And these are pretty familiar. Twitter, Facebook, Fox News, the list goes on and on and on. There are far more avenues than there are constraints, and the avenues are far more variable and accessible than are the constraints. And so I'm wondering now if we have a quantitative difference between animal parasites and ideas that is so great that it actually becomes a qualitative difference. And I think that that's an item for discussion. So here's one example that I think we all know well, and some of us at least know personally, and this is the idea that Ivermectin, which is merely a wonder drug in a whole lot of ways, the idea that this thing can function to cure a COVID infection has moved through the global population in a way that I personally find rather astonishing. But it's a familiar example from the parasitological world that we all know. From a quote from The Guardian, and I'm going to I'll simply read these to you. Last November, the WEIR TV news station in northern Florida aired a segment on Dr. Benjamin Marble, a local doctor who created a free telehealth website offering consultations for COVID-19. Well, Marble, the reporter said, had made it so, quote, patients don't have to pay a cent for coronavirus treatment, and believed that his site could replace Obamacare. So right away you're beginning to form an image based on these words of Dr. Benjamin Marble in your mind. And that image that's in your mind is a result of that mind being an avenue for infection with a whole lot of other information about parasites and infectious disease and treatments and prevention. To continue from The Guardian to the average viewer, that segment on ABC affiliate, which is owned by Sinclair Broadcasting, was a local news report touting a local service. So here's a case in which legitimacy is acquired through experience, at least in the mind of a local average viewer. What the report didn't mention, however, is that Marble is a member of America's Frontline Doctors, which is this right-wing political group It gained notoriety in summer of 2020 after some of its members appeared in a viral video touting unproven COVID-19 treatments as miracle cures. The founder of this particular group, Dr. Simone Gold, has headlined anti-vaccine rallies and is facing charges for storming the Capitol on January 6th. Also visible in the photo included in this clip was Dr. Stella Emanuel, a member who has claimed masks don't help curb the spread of COVID, and repeatedly said that some real-world illnesses were caused by people having sex in their dreams with demons and witches. Marble's telehealth page links to anti-vaccine information and website promoting unproven treatments such as the anti-parasitic drug Ivermectin. And now we get to an infective meme involving an individual that we all know that is a total fake. So somebody picked up Bill Campbell's picture from the web or from some source and made up a quote. My name is William Campbell. He won the Nobel Prize, blah, blah, blah. And the text that you're seeing above this picture is an absolute and total fabrication involving an individual some of us at least know and know well, a Nobel Prize winning individual who we know and know well as one of the most dignified, honest, and forthright scientists we have ever encountered. Now, however, that quote, that totally false quote, infective quote, accompanied by an image, is circulating widely on social media. Juanita Broderick, a prominent conservative with 500,000 followers, posted it on a Wednesday, and within 3 hours accumulated more than, this is on Twitter, with 12,000 retweets and likes, and other Twitter users. So this is an example of Twitter being an avenue for transmission of a meme, a made-up picture and words that can alter behavior and result in illness or death. So this is if you in fact don't get a vaccine and decide that you're going to treat yourself with ivermectin. Barb Bresnahan, Chief of Staff and Dean of Administration at Drew, where Bill Campbell does teach, post his time at Merck, told the fact checker the quote is false and the meme has been reported to Twitter. Now, this is all from the New York Times. Well, some analogies. This would be avenues and constraints, thinking exercises that probably could be used. In other words, pick something that infects a large fraction of the human population. The vertical has both vertical and horizontal transmission, like Aspergillus lumbricoides, and ask yourself, what really are the avenues and constraints on transmission, and how are those avenues and constraints established in various parts of the world where Ascaris is present. Malarial parasites are clearly vector-borne. For example, they are clear analogies to information technology, hardware and software. Schistosomiasis is an infective disease resulting from infection with parasites that are transmitted mainly vertically and through what we might call a screening box. Some other analogies, avenues and constraints to your thinking exercise. What factors, what properties of humans constitute S, E, I, and R, and I think that these are pretty obvious. If you're susceptible, if you're ignorant, you're susceptible, and if you're resistant, you're vaccinated by either prior experience or education. So I think this whole idea of avenues and constraints probably is a good one to carry into a classroom or any time that we have access to a potential audience that is susceptible, or an audience that is potentially susceptible, and give some thoughts to what are the avenues and constraints that we might have to actually infect these susceptible hosts with ideas and information and ways of looking at the world that convert them into the R group. And with that, I would be happy to try to respond to any questions you may have, and thank you very much.